In the previous chapter, you were introduced to the term heat. Now we will examine the different modes of heat transfer, specifically convection, conduction, and radiation. In this video, I'm going to look at more closely convection. All right. So convection occurs when heat is carried from one place to another. That is bulk fluid that is moving from one place to another. So it really only occurs in liquids or gases. So this occurs in fluids when the fluid is warm, such as in this example over here. We can see that a pot of water is being boiled with this heating element underneath it. And so the flame over here is heating the water molecules over here. Well, so suddenly these little molecules over here are now turning red for hot. And because they're hot, their volume will suddenly start to expand. And they'll have the same mass, so they become less dense. And remember from the previous chapter, on chapter 10, when we studied, or 11, sorry, when we studied fluids, we knew that there would be a buoyant force that would act upwards on them. And so these hotter molecules will start moving upwards. Then the colder molecules are here, relative to the ones that have been just heated up, now will become more dense compared relatively to the red ones, and they'll start to then be forced downwards this direction. And then this produces what we call a convection current. We typically classify these convection currents into two types. The natural convection, where the motion is occurring because there's a difference in densities. And that thermal expansion causes the hotter molecules to rise and the more dense molecules then lower down, and then you get this natural convection occurring. This occurs in not just like water, it can occur in, say, the air, when you've got hot air rising. If you look down lower in your notes, you'll see an example of where, say, you live near the sea, like Singapore, and you might have experienced that nice ocean breeze that you get during the daytime. And in this particular case, what happens is the ground is, during the daytime, heats up more quickly than the water. Now that's because the water has what's called a high specific heat. So the ground heats up more quickly, and therefore the air just above it will then heat up, and then it starts to rise. And as it rises, then the colder air that's over here will then start to sink, and then you'll get this nice convection current or this ocean breeze that occurs. Now in the evening or at nighttime, the opposite effect occurs. Now, because the water doesn't cool down as quickly, and so now it's warmer relative to the ground, and so then it's going to warm the air above it, and that air above the water is going to rise, and then it's going to cool. Eventually, the cool air is going to come down here along the ground, and so we'll get this nice land breeze if you're, say, on a ship. Well, in nature, you've got lots of examples, and you probably, if you ever take an environmental science class, they'll probably talk a lot about convection currents. And so here's another example of natural convection occurring. You get the ground warming up, and you get these what we call thermals. And this is what provides, if you've ever gone gliding or if you watched, eagles soar, they'll catch that thermal and they'll start circling around it and then start going higher and higher and higher. Whereas on the outside over here, this is the cooler ground, and so then you'll get that air is not flowing upwards. And so, so you can see the importance of convection currents just in nature. Also over here, in households, we see that we typically use a forced convection current to, where you might notice that the heater will be placed down below here, where you'll heat the air, and you know that hot air will rise and go up to the top. So if you place heaters in your house, you would have it down to the bottom ground section of your room or of the house, and then if you're actually trying to cool your house, then the air conditioners are actually placed near the tops of each of the bedrooms, because in that case you know that the hot air is going to rise, so you're going to want to have that cool air at the top, which will eventually sink down to your level. I've got a couple of demonstrations in class that I'll show you about convection. To summarize in this video, I just want to point out the key point here is that it's basically the bulk movement, so the bulk movement of matter from a region of hot to cold. And it occurs in fluids, all right? So that's like liquids and gases, all right? You don't have to worry about problem solving for convection currents, okay? So really just need to know this conceptually. And that's it for this video on convection.